Hey there! This is one in a series of build videos for our hydroponics project. Today, we're going to be going over a number of topics that will culminate in the mounting of the project board into the cart. We will not be doing too deep of a dive into any particular technology, but instead we'll be showcasing some of the steps we took to get it done. Stick around, it should be fun. In the last video, we prepared a piece of painted plexiglass for receiving components, and today we're going to hang equipment off of them. We're starting off with this connector cleat, the first part of our universal mounting system. It was printed to accept M3 countersunk screws, shown here. Along with the screw, which is used to secure the cleat against the acrylic plexiglass, we're using a nut, a rubber grommet, and a washer. The rubber grommet goes against the plexiglass to cushion it against the hard metal of the washer, to keep it from cracking. Here we have the cleat, along with the other two major components of our mounting system. And this part is the adapter plate. It is designed to slide over the cleat, holding it in place. This next piece is the actual equipment mount. It can be custom designed to accept any small piece of equipment. It was created to snap together with the adapter plate using two retainer pins that we printed. The pins have a tight tolerance and will snap into place, holding the pieces together. Once together, the three individual pieces will form a tight connection, supporting whatever components securely on the board. After that, we really only need to snap in our component. And making a return appearance from the last video, here's the project board, awaiting its first part of the build. To begin, I will find and mark the center with a ruler and a Sharpie. Then, I'll mark the first hole for the first cleat, and then I'll go ahead and use this battery-operated drill to make the hole. Do a little bit of cleanup, I checked for fitment and it fit well. So it's time to add the fastener. Here I'm using a screwdriver and a hex head bit. I hand tighten because I don't want to crank down on the plexiglass. Then I'll straighten it out and prepare for the next hole. So I went ahead and added the second screw, and then it's time to add the adapter plate. With that part on and secure, it's time to add the specific equipment plate. It goes on easy with a snap. And then, with the second pin in place and secure, it will be time to add the piece of equipment itself. In this holder, I'll be placing a fidgets vent hub. I won't be doing a deep dive into fidgets in this video. That will be a subject for an upcoming video series. I've got several more sensors to mount, so here's another cleat. Also, I have a link to my Thingiverse page for these adapter plates in the video as well as in the comments. So enjoy! And here's a quick look at how I stack the grommets, washer, and apply the nut in order to make sure that the plexiglass is safe and the item is secure. As I mentioned previously, the rubber grommet is there to make sure that the plexiglass doesn't crack. You wouldn't need a rubber grommet if you were mounting to aluminum or steel or any other kind of metal. Then we'll add on the second set of fasteners and tighten them down until they are secure, but only finger tight. After that, we'll add the adapter plate, followed by the equipment mount itself. The pin snaps into place just as easy as the first one had. Then, we add the second pin and secure it to the plexiglass. The device we're adding is larger than the first, but that's okay, because the universal adapter plate accounts for this. This is the digital input sensor. Its job will be interpreting digital signals, that is, changing between 0 and 5 volts DC. This adapter can receive and process up to 16 separate signals on one device. Next, we're adding a pH sensor with a BNC connector. pH is really important for hydroponics to measure the quality of the water for any particular series of plants. We have several other sensors to mount, but the details of mounting those are unimportant for this video. Instead, we're going to skip ahead to the mounting of the computer controller, which takes the signals coming from the vent hub via USB and processes them according to whatever rules exist in our orchestration flow. This is the tiny computer that we are mounting to the project board. Along with a database and reporting system in the cloud, it will control all of the activity for the hydroponics system. It had come with its own mounting bracket, and we chose to use that rather than print our own. We are using regular hex head screws, grommets, and nuts to attach this device to the project board. With the drilling done, we add the final fastener and secure the computer to the project board. This mini PC is an Intel Atom X5 Z8350 fanless mini computer with 4 gigs of RAM and 64 gigs of compact flash. It's 12 volts, so it works perfectly in my setup, and it has Bluetooth and Wi-Fi built in. I was able to pick this up on Amazon for just under $100 before tax. It's a fanless system, which means no moving parts. That's important for me because that means there's less to wear out and it'll probably run for a very long time with nothing breaking. I made use of the compact mounting bracket that it came with, and it was easy to mount up against the plexiglass and use with all the other equipment. And then it's time for the steps that I use to put an OS on this computer. I use a little app called Rufus. This particular one is 3.12 at the time of this video. And I'll be putting Ubuntu 18.04 onto this little computer. We do that by downloading the ISO image from Ubuntu, and then using Rufus, we burn it over to this little SanDisk USB flash drive. Honestly, it could be any flash drive as long as it's large enough to hold the image. And remember that whatever is on your flash drive is going to be destroyed. So if you have something important on there, don't use it. It didn't take very long to get Ubuntu installed once I had the ISO image burned on the flash drive. I had to mess around with the computer's UEFI. UEFI is a new BIOS standard and is a total replacement for BIOS. Standing for Unified Extensible Firmware Interface, it's a little bit more of a pain than the old way, but you can set it up to point the primary boot device at the flash drive, and then you just need to follow the prompts. Once Ubuntu was successfully installed, I configured Wi-Fi and updated the OS. Then I made sure Python and Node.js were in place and up to date, as well as any necessary libraries and drivers. So first, I'm going to show you some of the wiring organizers that I had printed up. I actually found them to be really useful and plan to reuse the concept down the road as easy fasteners. Here I'm actually pushing one of the wire organizers into the hole I drilled. It goes in tight and holds firm, but to pull it out, you just have to squeeze the back together and then it will pull free. Fidgets have their own interconnectivity method, using 3-wire connectors in a star formation with every sensor being directly connected with the hub. Here I have already wired up a couple, and I'm pushing one of the connector wires through holes I had drilled into the plexiglass to keep the presentation tidy. Every sensor will need to be connected to a hub, and each hub has 6 ports, allowing 6 sensors to be monitored. Fidget's hubs are connected to the computer using USB, and so any particular project can support multiple hubs. For this project, I settled on using 12 volts DC as the standard power supplied to all components. This makes things much simpler and more cost-effective. Here, I have already mounted a 12-volt positive bus block, and I'm continuing on by mounting the corresponding negative bus block. Both bus blocks have a jumper, red and black, that make every pole on each one of the bus blocks common, carrying the required voltage to every screw. I am mounting using M4 hex head screws, rubber grommets, washers, and nuts. Most of you know that wire stripping is a trivial task, and there are any number of ways you can go about it. I personally use this Nipix stripper. It's a time saver and ensures that exposed wire is the same length time and time again. So I could spend days on soldering, but there are already so many YouTube videos out there on the subject that it hardly seems worth it. Instead, I will just point out what I do, and if there are enough people that want to see me do a deeper dive, I'll consider doing a video in the future. But as it is, I'm just going to talk about what I do. I'll start with a soldering iron. This Heiko FX888D is arguably one of the best mid-price soldering irons I've ever owned. The precise temperature control, the even heating makes it literally so much easier to solder than anything I've ever had, and I definitely recommend it. Tinning a wire is the act of wetting a wire with solder before you attempt to solder it to some other item. Tinning will make all of your soldering efforts easier, faster, and less error prone. With my Heiko set to 630 degrees Celsius, I don't even need flux. It just works. Here, I am soldering four 18-gauge bell wires together into a single piece with the intent of joining it with a connector with another wire. When you're done, there should be even coverage with no globs or bald spots. If you've tinned your wire properly, joining the ends together should be easy. For me, I use these alligator clips helping hands to support all of my project pieces. I use this one from f-stop Labs. It has 5 flexible arms tipped with alligator clips to hold whatever pieces you need steady while you solder. Once you're ready, apply heat to the connector and wait for it to get hot. Swedge a little solder with the tip into the gaps to get all of the pieces wetted. Once hot, solder will flow in the direction of the heat, so add solder until the connector fills. At that point, the joint should be strong. This one is done, and it looks good. I'll make a little tug to ensure that nothing is loose, and it wasn't. I'll let it cool just a bit before I solder on the other side. Then I'll slide on some shrink tubing. Shrink tubing goes together with solder joints because it works so well to insulate and protect the exposed metal of the connection. I've pushed the shrink tubing up over the joint and will be using a heat gun to, well, shrink the shrink tubing over the wires and connector. I use a Wagner Ferno 300 that I picked up at one of the big box hardware stores for less than 30 bucks. It has 2 settings, 750 degrees and 1100 degrees, and quickly attaches the shrink tubing. Earlier, before I had started soldering, I had gone ahead and drilled the holes and added the wire organizers for the bus blocks. After that, I drilled the holes for where the wires would come up through to supply the 12-volt DC power anywhere it would be needed around the project board. I added a couple of more drill holes for a couple of more wire organizers, and I got about the business of attaching a wire with a soldered-on spade clip into the bus block. I pulled the protective cover off, and with a Phillips head screwdriver, I slid the spade clip under the connector and tightened down the nut. Then, I simply loomed the wire into the organizer and pushed the pigtail through so that I could solder it on the other side. With the 4 bell wires I had soldered and connected to the bus block earlier in place, it was time to bring out power to the solid-state relays. There are 16 total relays in this device, each capable of handling up to 30 volts at 8 amps. For this project, I will need no more than 8 relays, and so I am pushing the positive wires through to hook up to the pre-switch side of the relays. Now that they've been pushed through, I'll only need to loom them into the wiring organizer, trim them, strip them, and screw them down where they belong in the relay device. I'm starting on the first one now. And then tighten it down and make sure that it's secure. How about I apply a little time warp to speed this up? That was a nice smooth install. And now that that's done, let's move on to the power supply. I've installed a 12 volt 200 watt power supply, fanless, IP67 water resistance. It will power this entire board. The power supply is built using heavier gauge stranded wire, so I will be using crimp-on spade clips to make the connection. I will attach the crimp connectors with a specialized iWis crimping tool that has done a fantastic job for me in the past. It makes great connections with stranded wire, and I haven't had one fail yet. I load in the second connector as soon as the first is done, and moments later, I make the second crimp. As soon as this is done, I will be ready to screw these spade clips down to the bus block, which will provide 12 volts DC power to everything connected to it. Then, I just have to push the spade clips through the pre-made hole in the project board and screw them down to the bus block. We could probably use a little time warp here. So, we're here at what amounts to the last major modification we can do while on the project stand, which is to bring 12 volt power to the computer. We will be taking 12 volt off of the bus block and bringing it to the computer. I've done the math and I should have plenty of headroom on the 200 watt power supply to do this. The first thing to do is to push the two spade clips through the hole I had previously drilled and plug in the adapter. After that, I'll need to screw the spade clips down to the bus block. Here I am screwing the two spade clips down and put each of the two protective covers on each of the positive and negative poles of the bus block. The project board is finally ready to be unmounted and moved to the cart. After all that work, I'm finally going to hang the project board off the mounts I made in the last video, hanging under the cart. I have to admit that I'm just a little bit worried the screw holes will still line up. And here we are, hanging it up under the cart. As soon as I get these mount screws in place, it will mark the end of this phase and the beginning of the next. Then we'll start adding pumps, tubing, flow meters, sensors, reservoirs, lighting, and above all, plants. I really look forward to that, and I hope you guys stick around and see it all bear fruit. Pun intended.